Numbers are the basic building blocks of math, but they, however, are not as simple as you thought it may be. Today, I'm going to tell you about three basic terminology in maths that all numbers could belong to some extent actually. So maybe let's start with the easier ones, multiples. Multiples of an integer are the numbers within the original integer's timetable. In an easier way, if two positive integers multiply to make up a new number, the product given is the multiple of both integers. The reason why we're using integers instead of just vaguely numbers is because multiples needed to be whole numbers. For example, the multiples of 8 are 8, 16, 24, 32, and 40. But just because 8 times 1.5 equals 12 doesn't mean that 12 is a multiple of 8. As a number that multiplies 8, which is 1.5, is a non-integer. Also, just be aware that multiples can't be negatives, so there ain't anything like multiples of -8 or any type of these shit exist. Just pure positive integers larger than 0. So multiples are just numbers multiplied by whole numbers. But what about from a different perspective? Factors. Numbers that divide into another number perfectly without a remainder. In an easier way, if two numbers multiply to make them a new number, the two numbers are factors of the product they multiply to give. For example, as 1 times 8 gives 8 and 2 times 4 also gives 8, the factors of 8 will be 1, 2, 4, and 8. They all could multiply itself with another whole number to get 8, which makes it a factor of 8. So basically, we can get a general pattern from this. First thing, multiples of a number are infinite. It can go up to whatever high you want, but the first multiple of number will always be the number itself. Second thing, every number will all have at least two factors, 1 and itself, except 1 obviously. So is there a name specifically for numbers with two factors? There is actually one. Prime numbers, which can only be divided by 1 and itself, i.e. only having two factors. A few important facts right here about prime numbers. Firstly, 0 and 1 are not prime numbers. The reason for 0 is because 1 is not divisible with 0. There's just no answer for 1 divided by 0 until now, so factors of 0 doesn't even exist as a thing. Secondly, as we said before, prime numbers could only be divided by 1 and itself, and 1 is just 1. Therefore, it only has one factor, which does not fit into the category. Also, 2 is the only even number that is a prime number. Therefore, every number that ends with 2, 4, 6, 8, or 0 afterwards are never prime numbers. Additionally, 5 is also the only number that ends with 5, which is a prime number, as every number that ends with 5 afterwards is divisible by 5. Here are all the prime numbers up to 100. No specific patterns, just pure memorization. And obviously, you may ask, what's the point of primes? So primes basically exist for when you are finding something called prime factors. The difference between prime factors and factors are, we express numbers as a product of prime numbers when finding the prime factors of a number. For example, the factors of 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6, so it will be 1, 2, 3, 4, 6, 8, 12, and 24. However, if we wanted to find the prime numbers of 24, it will be 2 times 2 times 2 times 3. To find the prime factors of a number, we will have to use a method called the prime factor tree. What happens is we put the number on top and we will attempt to break down the number into two numbers that can multiply to become that number. So for example, 24 could be split into 2 and 12. Afterwards, we would see if the two numbers we have split could be broken down even further. For instance, although 2 could not be broken down further, 12 could be broken down into 2 times 6, and 6 afterwards could also be broken down into 2 times 3. After we confirm that there are no more numbers that can be broken down, we will circle up the remaining number we have got, and they will be the prime factors of the number. So just to summarize, multiples are the results of multiplying a given number by whole numbers. For example, 12 is a multiple of 3, as 3 times 4 equals 12. Factors are numbers that divide a given number exactly without a remainder. For instance, 3 is a factor of 12, as 12 divided by 3 equals 4. The connection between these two are that if x is a factor of y, then y would be a multiple of x. So basically, a factor fits into a number while multiples build up numbers. And for prime factors, it's basically breaking factors of a number down until the number could be expressed as a product of prime numbers. Every number will be uniquely expressed as a product of prime numbers, so there would basically be no confusion. The prime factor tree is just an easier way to break down numbers into prime factors, basically by finding numbers that are divisible to the original number until everything becomes prime. And that's it, basic categories of a number. But that's not the end. There's more smaller, deeper categories that we could go, and here is what you would need next.